Hey guys, welcome to the stream. Before we start the stream, I just wanted to say tomorrow I won't be streaming, and I'm probably gonna start streaming at 10 a.m. most days. That's right now for me it's 9:33 a.m. So I'm probably gonna stream an hour later or around 10. And just gotta get this set up. Alright, so let's get right into this now. So shifting functions, we have two videos to watch and then we have some practice problems to try.
So we have these two graphs that look pretty similar, y equals f of x and y is equal to g of x. And what they ask us to do is write a formula for the function g in terms of f. So let's think about how to do it. And like always, pause the video and see if you can work through it on your own. All right, well, what I like to do is I like to focus on this minimum point because I think that's a very easy thing to look at because both of them have that minimum point right over there. And so we could think about how do we shift f, at least especially this minimum point, how do we shift it to get to overlapping with g? Well, the first thing that might jump out at us is that we would want to shift to the left, and we'd want to shift to the left 4. So let me do this in a new color. So I would want to shift to the left by 4. So we have shifted to the left by 4, or you could say we shifted by -4. Either way, you could think about it. And then we need to shift down. So we need to go from y equals 2 to y is equal to -5. So let me do that. So let's shift down. So we shift down by 7, or you could say we have a -7 shift. So how do you express g of x if it's a version of f of x that's shifted to the left by 4 and shifted down by 7? Or you could say it had a -4 horizontal shift and had a -7 vertical shift. Well, one way to think about it is g of x is going to be equal to let me do it in a little darker color. It's going to be equal to f of x minus your horizontal shift. All right, horizontal shift. So x minus your horizontal shift plus your vertical shift. So plus your vertical shift. Well, what is our horizontal shift here? Well, we're shifting to the left, so it was a negative shift. So our horizontal shift is -4. And what's our vertical shift? Well, we went down, so our vertical shift is -7. So it's -7. So there you have it. We get g of x. Let me do it in that same color. We get g of x is equal to f of x minus -4, or x plus 4. And then we have plus -7, or you could just say -7. And we're done. And when I look at things like this, the -7 is somewhat is more intuitive to me. Is that I shifted it down. It makes sense that I have a -7. But at first, when you work on these, you say, "Hey, wait! I shifted to the left. Why is it a plus? Why is it a plus 4?" And the way I think about it is, in order to get the same value out of the function, instead of inputting, so if you want to get the value of f of 0, you now have to put x equals -4 in. And then you get that same value. You still get to 0. So that's, I don't know if that helps or hurts in terms of your understanding, but it often helps to try out some different values for x and seeing how it actually does shift the function. And if you're just trying to get your head around this piece, the horizontal shift, I recommend, not even using this example. Use an example that only has a horizontal shift, and it'll become a little bit more intuitive. And we have many videos that go into much more depth that explain that. But let's do another example of this. So here we have y is equal to g of x in purple and y is equal to f of x in blue. And they say given that f of x is equal to square root of x plus 4 minus 2, write an expression for g of x in terms of x. So first, let me just write an expression for g of x in terms of f of x. We can see once again it's just a shifted version of f of x. And remember, and I'll just write it in general, so g of x is going to be equal to f of x minus your horizontal shift plus your vertical shift. And so to go from f to g, what is your horizontal shift? Well, your horizontal shift is, if you take this point right over here, which should map to that point once we shift everything, your horizontal shift is 2 to the left. So, or you could say it's a -2 horizontal shift. So that should be -2. And then what is our vertical shift? Well, our vertical shift is we go from y equals -2 to y equals 3. So we're shifting 5 up. So this is a vertical shift of +5. So your vertical shift is 5. So if we just wanted to write g of x in terms of f of x, like we just did in the previous example, we could say g of x is going to be equal to f of x minus -2, which is x plus 2, and then we have plus 5. But that's not what they asked us to do. They asked us to write, they asked us to write an expression for g of x in terms of x. And so here we're actually going to use the definition of f of x. So let me make it clear. We know that f of x is going to be equal to square root of x plus 4 minus 2. So given that, what is f of x plus 2? Well, f of x plus 2 is going to be equal to, everywhere we see an x, we're going to replace it with an x plus 2. Square root of x plus 2 plus 4 minus 2, which is equal to the square root of x plus 6 minus 2. Well, that's fair enough. That's just f of x plus 2. Now, what is f of x plus 2 plus 5? So f of x plus 2 plus 5 is going to be this thing right over here plus 5. So it's going to be equal to square root of x plus 6 minus 2. And now we're going to add 5. We did a different color. So plus 5, so plus 5. And so what we end up with is going to be square root of x plus 6 minus 2 plus 5 is going to be plus 3. So that is equal to g of x. Just as a reminder, what did we do here? First, I expressed g of x in terms of f of x. Where I say, hey, to get from f of x to g of x, I shift 2 to the left. 2 to the left. It's a little counterintuitive that it's plus 2 makes it a shift of 2 to the left. If this was minus 2, it would be a shift of 2 to the right. But like I just said in the previous example, it's good to try out some x's and to see why that makes sense. And then we shifted 5 up. So this was g of x in terms of f of x. But then they told us what f of x actually is in terms of x. So I said, okay, well, what is f of x plus 2? F of x plus 2, we substituted x plus 2 for x, and we got this. But g of x is f of x plus 2 plus 5. So we took what we figured out f of x plus 2 is, and then we added 5, and that's what g of x is. And then we are all done.
Alright, so now we're going to watch the video on graphing shifted functions and then do the practice problems.
We're told the graph of the function f of x is equal to x squared. We see it right over here in gray. Is shown in the grid below. Graph the function g of x is equal to x minus 2 squared minus 4 in the interactive graph. And this is from the shifting functions exercise on Khan Academy. And we can see we can change the graph of g of x. But let's see, we want to graph it properly. So let's see how they relate. Well, let's think about a few things. Let's first just make g of x completely overlap. Well, actually, that's completely easier said than done. Okay, there you go. Now they're completely overlapping. And let's see how they're different. Well, g of x, if you look at what's going on here, instead of having an x squared, we have an x minus 2 squared. So one way to think about it is, when x is 0, you have 0 squared is equal to 0. But how do you get 0 here? Well, x has got to be equal to 2. 2 minus 2 squared is 0 squared, if we don't look at the negative 4 just yet. And so we would want to shift this graph over 2 to the right. This is essentially how much do we shift to the right. It's sometimes a little bit counterintuitive that we have a negative there, because you might say, well, negative, that makes me think that I want to shift to the left. But you just have to remind yourself is like, well, okay, for the original graph, when it was just x squared, to get the 0 squared, I just have to put x equals 0. Now to get a 0 squared, I have to put in a 2. So this is actually shifting the graph to the right. And so what do we do with this negative 4? Well, this is a little bit more intuitive, or at least for me when I first learned it. This literally will just shift the graph down. Whatever your value is of x minus 2 squared, it's going to shift it down by 4. So what we want to do is just shift both of these points down by 4. So this is going to go from 9, this is going to go from the coordinate 5, 9 to 5, if we go down 4, 5, 5. And this is going to go from 2, 0 to 2, negative 4. 2, negative 4. Did I do that right? I think that's right. Essentially what we have going on is g of x is f of x shifted 2 to the right and 4 down. 2 to the right and 4 down. And notice, if you look at the vertex here, we shifted 2 to the right and 4 down. And I shifted this one also. This one also I shifted 2 to the right and 4 down. And there you have it. We have graphed g of x, which is a shifted version of f of x.
Alright, so now we're going to do the practice problems for shifting functions. So the graph of y of x cubed is shown on the grid below. Which of the following is the graph of y equals x minus 2 cubed? So we know that inside of, if you change it inside of the parentheses, that would be our horizontal shift. So we want to shift this over to negative 2. So, and what he was just saying is this, if you make this equal to 0, or if you have 0, right, 0 cubed is 0. So we want this to equal 2. Yes, because we're subtracting the horizontal shift. So we actually want a positive 2 shift. So we need to make this equal 2. So in the first one, it equals 2 on a horizontal shift. this would be a -2 horizontal shift. So that is not the correct one. And we'll keep going. The graph of g of x is shown on the grid below. Which of the following is the graph of g of x minus 4 minus 2? So for the horizontal shift, we'll take the -4, and we want to actually take a +4 horizontal shift because we're supposed to subtract the shift. So we want a +4 horizontal shift. So that would land us right on the y-axis. And a -2 horizontal shift. So we want to go down. So we're on the y-axis, and we're starting on -2. So we want to go down to -4. So we want our starting point to be 0, 0, -4. So here's one that's 0, -4. This one wouldn't work because they went up 2 for the vertical axis on the vertical shift. This one wouldn't work because they went backwards. They did a negative shift for the horizontal shift, and this one they also did a negative shift for the horizontal shift, but they went down 2 correctly. This one they went up 2. So let's check our answer, and we got it right. So the graph of g of x is transformation of the graph of y equals f of x. Write a formula for the function of g in terms of the function f. So in terms of f, so we equals f of x, and then we want to do our horizontal first, our horizontal shift first. So it goes over 1, 2, 3, 4. It goes over 4, -4, because we're moving back 4, and then it goes down from 2 to -5. That's -7. So -4, -7. So we want to do horizontal first, and we subtract horizontal. So if we're subtracting a -4, it's just like adding a +4. So we can just write in +4. And then we want to add -7, and we can just subtract 7, because if we're adding a -7, it's the same thing. So we'll check, and we got it right. So the graph of y equals f of x is a transformation of the graph of y equals h of x. Given that h of x equals -x minus x, okay, negative, parentheses, x minus 1, quantity squared minus 1, write an expression for f of x in terms of x. So we can write in the f of x equals h of x let's see, right? So there seems to be no horizontal shift, so it's just a vertical shift of 1, 2, 3, 4, 5, 6. Yes, because we're going from -1 to +5. So there's no horizontal shift, but we do have a vertical shift of +6, because we're doing h of x. So h of x to get to f of x is a positive shift of 6. So now we want to take f of x. I didn't do that in the first one. Equals and we'll replace h of x with the this right here of h of x with so it's negative x minus 1 squared minus 1 plus 6. So we will square everything inside of here. So it's we have to do here. We'll make this bigger. It would be, and I'll move it over. X minus 1 times x minus 1. So do x times x, and that's x squared. And then x times negative 1, and that's negative 1x. X times negative 1 is negative 1x. And then negative 1 times negative 1 is positive 1. So we have x squared minus 2x plus 1. So we'll take f of x equals x squared minus 2x plus 1, all in parentheses with a negative in front. And then we'll figure out this last 6 minus 1. Last part is 6 minus 1, which is 5 plus 5. Sorry about the handwriting again. F of x equals, so we'll distribute the negative to be negative x squared plus 2x minus 1 plus 5. So we have f of x equals negative x squared plus 2x, and then 5 minus 1 would be 4 plus 4. So we'll try that answer. It is negative x squared plus 2x plus 4. Check. And we're done with shifting functions. We'll do stretching functions as well today. And all right. Here we go. Stretching functions.
So this red curve is the graph of f of x, and this blue curve is the graph of g of x. And I want to try to express g of x in terms of f of x. And so let's see how they're related. So we pick any x, and we could start right here at the vertex of f of x. And we see that at least at that point, g of x is exactly one higher than that. So g of 2, I could write this down. G of 2 is equal to f of 2 plus 1. Let's see if that's true for any x. So then we can just sample over here. Well, let's see, f of 4 is right over here. G of 4 is 1 more than that. F of 6 is right here. G of 6 is 1 more than that. So it looks like if we pick any point over here, even though there's a little bit of an optical illusion, it looks like they get closer together. They do if you try to find the closest distance between the two. But if you look at vertical distance, you see that it stays a constant. It stays a constant 1. So we can actually generalize this. This is true for any x. g of x is equal to f of x is equal to f of x plus 1. Let's do a few more examples of this. So right over here, here is f of x in red again, and here is g of x. And so let's say we picked x equals -4. This is f of -4, and we see g of -4 is 2 less than that. And we see whatever f of x is, g of x, no matter where we go, no matter what x we pick, g of x seems to be exactly 2 less. G of x is exactly 2 less. So in this case, very similar to the other one, g of x is going to be equal to f of x, but instead of adding, we're going to subtract 2 from f of x minus 2. Let's do a few more examples. So here we have f of x in red again. I'll relabel it, f of x, and here is g of x. Here is g of x. So let's think about it a little bit. Let's pick an arbitrary point here. Let's say we have in red here, this point right over there is the value of f of 3. So that, or f of -3, I should say. This is -3. This is the point -3 f of 3. So -3 f of 3. Now g hits that same value when x is equal to -1. When x is equal to -1. So let's think about this. g of -1 is equal to f of -3. f of -3 is equal to f of -3. And we could do that with a bunch of points. We could see that g of 0, which is right there. Let me do it in a color you can see. G of 0 is equivalent to f of -2. So let me write that down. G of 0 is equal to f of -2. We could keep doing that. We could say g of 1. G of 1, which is right over here. This is 1. G of 1 is equal to f of -1. G of 1 is equal to f of -1. So I think you see the pattern here. G of whatever is equal to the function evaluated at 2 less than whatever is here. So we could say that g of x is equal to f of, well, it's going to be 2 less than x. So f of x minus 2. So this is the relationship. G of x is equal to f of x minus 2. And it's important to realize here, when I did f of x minus 2 here, and remember, the function is being evaluated, this is the input. X minus 2 is the input. When I subtract the 2, this is shifting the function to the right, which is a little bit counterintuitive unless you go through this exercise right over here. So g of x is equal to f of x minus 2. If it was f of x plus 2, we would have actually shifted f to the left. Now let's think about this one. This one seems kind of wacky. So first of all, g of x, it almost looks like a mirror image, but it looks like it's been flattened out. So let's think of it this way. Let's take the mirror image of what g of x is. So I'm going to try my best to take the mirror image of it. So let's see, it gets to about 2 there. Then it gets pretty close to 1 right over there. And then it gets about right over there. So if I were to take its mirror image, it looks something like this. Its mirror image, if I were to reflect it across the x-axis, it looks something like this. It looks something like this. So this right over here, we would call, so if this is g of x, when we flip it that way, this is the negative g of x. Negative g of x. When x equals 4, g of x looks like it's, I don't know, about -3.5. You take the negative of that, you get positive. I guess it should be closer to, you get positive 3.5 if you were to take the exact mirror image. So that's negative g of x. But that still doesn't get us there. It looks like we actually have to triple this value for any point. And you see it here. This gets to 2, but we need to get to 6. This gets to 1, but we need to get to 3. So it looks like this red graph right over here is 3 times this graph. So this is 3 times negative g of x, which is equal to negative 3 g of x. So here we have f of x is equal to negative 3 times g of x. And if we wanted to solve for g of x, write g of x in terms of f of x, we would write, dividing both sides by negative 3, g of x is equal to negative 1/3 f of x. Negative 1/3 f of x.
Alright, so now we're going to watch the next two videos.
G of x is a transformation of f of x. The graph here shows this is y is equal to f of x, a solid blue line, and this is y is equal to g of x as a dashed red line. And they ask us, what is g of x in terms of f of x? And like always, pause the video and see if you can give a go at it, and then we're going to do it together. All right, so when you immediately look like it looks like g of x is kind of a thinned up version of f of x. It seems like if you were to compress it towards the center, that's what g of x looks like. But let's put a little bit more meat on that bone and see if we can identify corresponding points. So for example, if we were to look at f of negative 6, so f of negative 6, that seems like it corresponds, or it gives us the same value as f of negative 6. And we want to find the corresponding point. So we've hit this minimum point, we're coming back up. Hit the minimum point, we're coming back up. It seems like the corresponding point right over there is g of negative 3. So let's write that down. Let's see, it looks like f of negative 6, and it is equal to g of negative 3. These are corresponding points. If you apply the transformation at the point f equals, at the point negative 6 comma f of negative 6, you get to the point negative 3 g of negative 3 right over there. Let's do a couple of more. If you look at f is, so f of 2 looks like it corresponds to g of 1. F of 2 corresponds to g of 1. So let's write that down. F of 2 looks like it corresponds to g of 1. And once again, I'm looking at where the functions hit the same value, and also optically, I'm just looking at, well, it looks like it's the same part of the function if we assume g of x is a squeezed version of f of x. And so in general, it looks like for a given x, so we could say f of x is going to be equal to g of, well, whatever you have in here, it seems like we have half the value over here. So g of x over 2. Or if you wanted to think of it the other way, if you want to say g of x is going to be f of, well, whatever we have here, it's f of twice that. So f of 2x. And we see that that is one of the choices, that g of x is equal to f of 2x. Whatever the x that you input into g of x, you get that same value out of the function when you input 2 times that into f of x. And these seem to validate that. It looks optically like that we shrunk it down. One way to think about it, when you multiply the input into a function by a number larger than 1, it's going to compress. It's going to make things happen faster. The input to the function is going to increase or become negative faster. So it thins it up. And if that doesn't make intuitive sense, you can also just try some of these values, and I encourage you to try more. Find the corresponding points where the f's and the g's seem to match up, and you'll see over and over again that to get the same value, you have to put 2 times as much into f as you have to put into g. Hopefully that helps.
Alright, now we're going to watch the last video, and then we're going to try some practice.
So we're told g of x is a transformation of f of x. The graph below shows f of x as a solid blue line, so this is a graph of y is equal to f of x. And g of x is a dotted red line, so that's the graph of y is equal to g of x. What is g of x in terms of f of x? And they gave us some choices here, and I encourage you to pause the video and see if you can figure this out. Well, there's a couple of ways that you could think about it. One is if you just eyeball it, it looks like if you flipped f of x over the x-axis, it looks a little bit like g of x, but g of x looks like a version of that that's diminished a little bit. So for example, if you were to flip it perfectly over the x-axis, you would get something that looks like, and I'm just going to sketch it. So if you just flipped perfectly over the x-axis, you would get something that looks like this. And trying my best to eyeball it. So it would look something like this. If you perfectly just flipped it over, it would look something like that. I might not get it perfectly right, but that would be this right over here. So let me be clear. If this is y is equal to f of x, then this line right over here that I just drew, that would be y is equal to negative f of x. So, because whatever f of x would give, you just take the negative of it. You're flipping over the x-axis. And now g of x looks like a diminished version of that. And if I were to just eyeball it, it looks like it's roughly 1/3 of this. So my initial guess, and we can verify this a little bit, is that this right over here is 1/3 the value of this. So I would say it is, so g of x is equal to 1/3 of negative f of x, or negative 1/3 of f of x. And that is not one of the choices, which makes me extra cautious. But let me just emphasize why I like this choice. Because we said this is negative f of x right there. And it looks like for any x value, what g of x is 1/3 of that. So instead of getting to 4, we're getting to a little bit over 1. Instead of getting to 3 right over here, we're getting to 1. Instead of getting to 1 right over here, we are only getting to 1/3. So it looks like it is 1/3 of this line that I just hand drew, which is negative f of x. So it would be 1/3 of negative f of x, which would be negative 1/3 f of x. Once again, not a choice here, but let's actually look at some values. So if we said, let's see some values where it looks like we're hitting integer values. So for example, right at this point, right over here, it looks like f of negative 7 is equal to negative 1. It looks like g of negative 7 is right. So it looks like g of negative 7 is equal to positive 1/3. Positive 1/3. If I am just eyeballing it. So that seems consistent with this, because if f of negative 7 is negative 1, you take the negative 1/3 times that, and you get positive 1/3. We can do that at a couple of other places. If we look right over here, it looks like f of negative 1 is equal to negative 3, and it looks like g of 1 is negative 1/3 times that. Negative 1/3 times that is that point right over there. Negative 1/3 times negative 3 is positive 1. So g of, I'm doing g's color in that red color. So we get, for that point right over there, we get g of negative 1 is equal to positive 1. So once again, this is negative 1/3 times this right over here. So I feel pretty confident in my answer. G of x is equal to negative 1/3 times f of x. Once again, negative f of x we just flipped over, and then multiplying it by the 1/3 diminishes that, which we see right over there. So I feel pretty confident with my none of the above.
All right, now we're going to practice transforming functions. So g is a transformation of f. The graph below shows f as a solid blue line and g as a dotted red line. What is the formula of g in terms of f? One second. All right, so g is a transformation of f. F is the solid blue line and g is a dotted red line. It's the formula of g in terms of f. So this red line is g, this blue line is f. So we'll find like points right here. F. G is 2 less, so we'll try negative 4. G is 2 less. Negative 2. G is always 2 less than 2 less vertically than f. So we know that vertical goes outside the parentheses and you add it. So if we're going down 2, you subtract. So these are both horizontal shifts. So we'll check, and we got it right. So G is a transformation of F. The graph below shows F as a solid blue line and G as a dotted red line. So it obviously starts out as a reflection, so it's going to be a negative before F, and it also is stretched. So if it's -3 down here, if it's -3, you can see it's along the -3 line, and it's 9 up here. Well, that's time. Well, what do you do? What do you do to -3 to get it to equal 9? Well, you multiply it by -3, and you can see here at negative. Let's see another good point where it stops it. Right here at -2. Right there, -2. You can see at 5 on the x-axis up here, it stops at 6. So -2 times -3 is +6. So it'd be -3 f of x. -3 f of x, if I can click on it. And my stream is running very not well. I'm not sure why. If you guys can even watch it right now. Alright, sorry about the stream running so terribly. I'm not sure why it is like that. It's not running well, but we are almost done, so I'm going to finish it up and fix it next time. So, hopefully it'll be better. Oh, this is like unwatchable. Yeah. Well, so I think it's a problem with my encoder, which might be a problem with what I'm using. Anyways, we'll check that we got it right, and we did. So G is a transformation of F, and the graph below shows F as a solid blue line and G as a dotted red line. So what's the formula of G in terms of F? So one second, guys. There we go. Alright, just had a brain freeze for a second. So here, where y equals 1, x equals 3 for f, and equals 1.5-ish for g. So we'll try that with here at when y equals -2. This x is about -4, and this one is -2. So if you're catching, if you're seeing a relationship, it's always half. It always seems to be half of whatever the blue line is. The red line is always half. Horizontally. Sorry, guys. It's always half horizontally of whatever the blue line is. So we'd obviously put it inside the parentheses with the x. And we want g in terms of f. So we want to see how you'd get from g to f. And it would be taking f and multiplying it by 2. Or taking g and multiplying it by 2. So I think it would be. Now it's not negative. So that rules out these two. And you take it and multiply it by 2. So that would be this one. There we go. Next question. Alright, G is a transformation of F. The graph below shows F is a blue line and G is a red line. What is the formula of G in terms of F? So, G in terms of F. So, this is another horizontal shift. You can see it shifts over to the right 2 to get from red to blue. Always to the right 2. Yep, so It's a horizontal shift, so it's going to go inside. And for normal horizontal shifts, you subtract. So if we from to get from F to G, it should be it's a shift of -2. But if you subtract, it should be +2. Let's see if I'm right. And there we go. So I hope that made sense. If you guys have any questions, just comment. Uh, and yeah, there we go. And now my stream seems to be, whatever. Alright, so thank you guys for watching. I won't be streaming tomorrow, but I might be streaming the following days starting at 10 o'clock ish. Alright, thank you.